Hi folks, Mr. Long here. I'm going to work through the type 3 tangent problems in calculus. And so what we're going to do is I'll take a few minutes or a minute and just describe the types of questions. So oh, you may hear a dog barking in the background. In type 3, what we have is this type of situation. So we have an equation of a parabola, and it's kx squared plus bx plus 10. So in other words, we don't know the value in front of x squared. We don't know the value in front of x. And we call it k and b. Normally we would call it a and b, right? Ax squared plus bx plus c. But because in this type of problem, the a value refers to the x value where the tangent is located. Okay, so we have to make it k. Anyway, we have k and b that we're trying to figure out. So in this type of question, what we know is we know where the tangent is, and we know the equation of the tangent. We just need to figure out some things about the actual function. So it's kind of going backwards, right? We know the location of the tangent. We know the equation of the tangent. So what I want to go over with you right now is actually, so here's the information that we have, and I've plotted it on a graph, okay, just to help you understand. So we know that the tangent is 7x plus 9. Well, that means the y-intercept is 9 and has a slope of 7. So it's a steep slope going up. We know the point of tangency is at 1, 16. So that's right there, right? 1, 16. So 1, 16. So that's the point of tangency, right? So we could have, like, the curve could look like this, right? Something like that. And we would have a point of tangency right there. On the other hand, it could also look like this. Okay, so there's two possibilities for that tangent. It could be a parabola that's opening up or a parabola that's opening down. We don't know, but we are going to figure that out. All right, so that's to begin with in terms of understanding. And I can't state again how important it is to start with a rough sketch like this. And even when I'm marking your tests, if you've got a sketch, I know you understand what's going on. If you just put a bunch of algebra down and it's wrong, it's very hard for me to give you marks. But if you start out with a picture that shows very clearly you know what's happening, well, that's a little bit different. That, again, it's about doing a good job selling your solution. Okay, so what do we need to do? Well, in every case with all of these, you're going to work with f at x and you're going to work with f prime at x. Okay, f at x being the actual function, the original function, and f prime of x being the tangent slope function. Okay, that's the function that describes the slope. Okay, so let's start with f at x. Oh, by the way, we know that our a value is 1, right? Because it's 1, 16 is the point of tangency. So I come right to here, and so f at x equals kx squared plus bx plus 10. I don't know what k and b are. Then I know, but I do know that 16 is the y value for the point of tangency. Well, that point of tangency is on the parabola and on the tangent. So, and we do know that the point of tangency is always at a, f at a. Right? I know even function notation is still difficult, right? And it is challenging. So that's an x value there, and that's a y value that corresponds to it, okay, which is right here. Okay, so let's just move this up then. So what I do is I have this as my original function. I substitute in 1. If I sub in 1 to the original function, it has to work out to 16 because that's the y value. Okay, so f at a is worth 16. That's the y value at that point of tangency. And I sub in the x value of 1. So I end up with this equation. K times 1 squared is just k. B times 1 is just b. And then I've got plus 10. So I've got this equation, 16 equals k plus b plus 10. That's kind of a weird equation. I'm going to minus 10 off both sides so that I can do some algebra a little bit simpler. So I end up with this equation right here. 6 equals k plus b. And that's based on the relationship between the x and the y value at the point of tangency. So I used f at x. Okay, and so I have one equation with two unknowns. I can't solve that. So what I need to do is introduce another equation. Okay, and for those of you that took physics last semester, you probably have more of an opportunity to practice this. This is stuff that goes way back to grade 10. But I think in physics probably you do a lot of solving equations with two unknowns. All right, so now what I do, I need to do another equation. Well, luckily I can use the tangent slope equation. Okay, the tangent slope is 2 times k times x plus b. So again, where does that come from? Well, look back up here. There's the original curve. So the original curve is kx squared plus bx plus c. Well, kx squared, what's the slope of kx squared? 2 multiplied by k multiplied by x. And here's a straight line, b times x plus 10. B can be any number, right? So what's the slope of that line, bx plus 10? Well, it's just b. It's just the number in front of x. So again, I come back down here, and there is my tangent slope function right there. Okay, that's my tangent slope function. And so I know that that's f prime at x. So what I'm going to do is now make f prime at a. Let's figure out what that is. Well, I know that a is worth 1, and I know, and here's the neat thing, is what is that tangent slope? Well, I know it's 7. How do I know it's 7? Well, I'm pretty sure the actual equation of the tangent was given. The equation of the tangent was 7x plus 9. So that right there is f prime at a, right? That's f prime at a. It's not a very good f prime, is it? F prime at a. So that is the slope of the tangent. Y equals mx plus b. And m in this case is the tangent slope. So I can set the tangent slope function equal to 7. Okay, that's the tangent slope. It's given. So then I go through and I substitute everything in. So from here to here, I know that the tangent slope is 7. And then I replace, it's 2kx plus b, so I replace x with 1. And then I simplify. 2 times k times 1 is 2k plus b. So that's an equation for the relationship between the tangent slope and the tangent slope function. So now I've got 2 equations and 2 unknowns. Okay, 2 equations and 2 unknowns. By the way, I'm numbering my equations. I should have mentioned that earlier. So the original function, f at x, the equation that we created there, I'm calling 1. Then the equation from f prime at x, so this is the f prime equation, this is the f equation, the function, and then the other one is f prime. So I'm numbering those equations as 1 and 2. Well, if I want to eliminate a variable, I can just subtract those equations. Because if I subtract b's, b minus b is gone. So I do 7 minus 6, well that's 1. Okay, then I do 2k minus k, which gives me k. And again, the b minus b is gone. So k equals 1. I call that equation 3. So what I can do then is I can put equation 3, which is k equals 1, back into equation number 1. Okay, so this is 6. The k right there I now know is 1. So 6 equals 1 plus b. Well, what do I add to 1 to get 6? Okay, it's 5. So b equals 5. So now I know in that equation it was k x squared plus bx plus 10. So the k value is 1, the b value is 5. And if I have a k value of 1 and a b value of 5, then I know I get the tangent y equals 7x plus 9, and the point of tangency will be 1 and 16. Okay, so that's the whole point of that. I started out with this. So if you notice, in the other questions, I started out with the original function, and then I figured out the tangent. In this case, I started out with the tangent and I figure out the original function. Okay, so that's a little bit trickier. That's type 3, and I apologize, that was a little bit of a longer video, but hopefully that helps as you go through these. Okay, again, don't hesitate to rewind, make notes, etc.